Welcome to GemChem. Now today's video is on alkenes part 3, and here we will deal with another method of generation of alkenes using pyrolytic elimination, and a special case of pyrolytic elimination is Chugaev elimination. So we will learn here these two methods of preparation. Now before starting, if you have not watched alkenes part 1 and part 2, please do watch it before watching this. It will be helpful. I will give the link in the description box. Now let us start. Now this pyrolytic elimination takes place for those compounds which undergo elimination on heating without any reagents, and this particular reaction is a gas phase reaction and it occurs for carboxylic esters and xanthates. Now we will see what are xanthates in this video in later part. Now we will deal with carboxylic ester during the pyrolytic elimination of carboxylic ester. Now see, this has a special condition for it. These carboxylic ester or xanthates must have alkyl group with a beta hydrogen. No solvent is required and it follows EI mechanism. It is a scene elimination, that is, elimination takes place from the same side of the bond, and the reaction proceeds via a 6-membered cyclic transition state, and the limitation is maximum portion of the ester is carbonized as it needs higher temperature. Now this is an example. See, this is a carboxylic ester. This functional group is ester. So if you have not watched the video on functional groups and nomenclature, please do watch it. There I have already described what are the groups of esters. So I will give the link in the description box. Now see this one. Here this is the ester group, and what is beta hydrogen? This carbon is alpha carbon and this carbon is beta carbon, and this beta carbon has one hydrogen. So it has a beta hydrogen. So this condition is being checked. Now we need to see what happens. We see that a double bond comes here and this bond breaks up, right? So what is the mechanism? We have to know. Let us see what is the mechanism. Now first we will draw this structure only. Now from this we will start. Now this bond is a carbonyl bond. So the electron density of the carbonyl carbon double bond will be attracted towards oxygen, and oxygen will bond with this hydrogen. Then this hydrogen will give up the bond to this carbon carbon, and then this carbon oxygen bond will break. So what is the ultimate fate? If we draw it clearly, if this is our structure, we see that this bond is being given to hydrogen, this one to here and this one to here. Now what is the transition state which we can see? The transition state looks like this. Carbon, one bond remains intact, one bond is being formed, so dotted line. This hydrogen bond breaks, so dotted line. This hydrogen and oxygen bond is newly formed, so dotted line. One oxygen and carbon bonds remain intact, right? So one dotted and one straight line, and this one R remains as it is, and this here also one oxygen bond comes with the carbon and this bond has already been broken. So this is our cyclic transition state. This is 6-membered. How can we say it is 6-membered? 1, 2, 3, 4, 5, 6. This is a 6-membered cyclic transition state. And what is our ultimate product which we get? We get actually this product, right? So what happens? This one, C double bond, C double bond. So this is our alkene plus an acid, that is this O bonded to H, and this one R, and this one is double bond O. So this is an acid. Now we will see another reaction. We need to convert this FISCHER projection into the NEWMANN projection. So while converting, the method is being given in basic introduction part 1 video of organic chemistry. Please do watch it. I will give the link in the description box. Now see this one. This structure will be written as this: pH HOCOCH3, right? and the back carbon as D, H and PH. Now first we can eliminate, there is two types, one where we can eliminate hydrogen and another where we can eliminate deuterium. So we will focus first on hydrogen elimination. So let us see. For hydrogen elimination we need to convert the structure. So first we rotate the front carbon in clockwise direction and backward carbon in anti-clockwise direction. So the structure which is obtained is like this. See this one, PH, O, CO, CH3, H, PH, H, PH and D. Right. Now we will write the product. On elimination of this two, we get actually this product. C, PH, D, PH, H. This is our first product and this product is most likely. And in the second case what happens, we will try to see in the second case, this is the diagram, right? But here elimination can also occur and we can get a cis-stilbene like this. Let us see, it will be like this. That is here where will be 2 pH and here will be H and H. And another thing will be, there will be a problem. In this case, this portion, if we focus, pH and pH will create a repulsion, steric repulsion. So this product is less likely. So this is the main product which will be obtained. Right. Now let us go to our next part. Now these are the other two examples. Now before seeing this, we have already discussed about the generation of alcohols. So there we have already observed the two types of product can occur based on the substitution. So in this case also, hydrogen can be eliminated from this portion or this portion, right? Because this is alpha, beta, that is this portion is alpha, beta and this is also alpha, beta. So hydrogen can be eliminated from this side and this side. So the most substituted product is the major product. In this case we see there is two ester groups, right? So elimination will take place for both types. Now we will see what is Chugaev elimination. This is a special case where pyrolysis of xanthates occur. Now xanthates are prepared from alcohol and carbon disulfide under alkaline condition followed by treatment with iodomethane. Elimination proceeds at significantly low temperatures as this is entropically favorable. Previously we had got acid. Now in this case we will get two products. In case of acid there was one product which was generated as byproduct. Here there will be two byproducts. So total there will be three products. Much disordered, so it will be entropically favorable. Pyrolysis exhibits negative entropy of activation. Molecules more restricted in geometry in transition state than in substrate. Now similarly from the previous expression we know that this is scene elimination and this is the example. Now this is first part is xanthate formation, how xanthates are being formed. Now see this one, we take an alcohol. This is the alcohol taken. Now to it added carbon disulfide. Now this O, this oxygen bonds with this carbon disulfide. And what is the mechanism? Let me see, draw it. Now see, this is the mechanism. This O double bond attacks this carbon and this bond opens up and this hydrogen is then being eliminated. Now next what happens? Next we see that this one abstracts a CH3 group. From where does it obtain the CH3 group? It obtains the CH3 group from methyl iodide which is being added later. So this sulfur negative attacks this methyl and this iodine goes away. Now see, this is an example of Chugaev elimination. Now this is the xanthate, same mechanism as seen before. That is, what happens? This sulfur attacks the hydrogen by opening its double bond, and then hydrogen gives up the electron to carbon single bond, and this carbon single bond gives up the electron to carbon oxygen bond, and we get this one as the byproduct, and this is our main product. Now we will see that how the three products are being generated. Now see, we have obtained this as our second byproduct, previously which was acid. This is now the byproduct. Now what happens here? Here another elimination takes place, that is, this hydrogen is being donated here and this SCH3 gets away. Now this hydrogen is basically being bonded to this one, so we actually, this is the arrow portion, so we get finally as this one. That is, we get S double bond C double bond O and CH3 SH. These are the two byproducts. So there is formation of total 3 products. So it is more entropically favorable. Now these are few examples. Now see this one. Previously we had already seen dehydrogenation of alcohol, right? So see this one. Here when 60% of H2SO4 is given, there is removal of water plus rearrangement. So this is important. Whereas when this reagent, that is CS2, KOH, then CH3I and heat is given, then this hydrogen is being removed. So for here we get alkene with more substitution, whereas there is a presence of rearrangement, and in this case we have alkene which is normal. See this one also, CH2OH present here. For this H3PO4 we get more substituted product. For this case we get less substituted product. Here no rearrangement has been taken place. So this much for today. Thank you for watching. Do not forget to like, share, subscribe and comment.